I would like to tell you all the formulas that we will be using throughout this video, and if you don't know what they mean, then I'll try to explain it the best that I can. So this is the formula for velocity equals wavelengths times frequency. And so let's say that you didn't know what velocity was, but you have like a degree. Well, this is the formula for velocity. And you'd plug in the degree right there, and that way you just plug it all in and you'd find speed of sound. And this is the Doppler effect formula, and this is the frequency that the observer was hearing. This is the actual sound of the frequency, so source. This is the speed of the source, and this is the speed of the observer. That's why there's a little O. You don't have to put the O, but it's good to know. And this is the speed of air, so with the formula right here, you can find the speed of air, and then you're going to plug that in right there. And this is the decibel formula, and this is decibel, and these are intensities. I apologize for messing up right there. So now let's go about solving the problems. From trough to crest, the distance is 14 meters. What is the amplitude? So from up here to up here, this is 14. So 14 divided by 2 should give us the amplitude, since it's half of that, which is 7. So 7 meters is the amplitude. On to the next problem. In the diagram below, the horizontal distance between the dots is 8 meters. What is the wavelength of the wave? So as you can see, this and this is obviously from crest to trough. So therefore, that's half of what it is. So it should be 8 times 2 equals 16. So 16 meters is the wavelength. And then on to part B, or part A. Using 331 meters per second, what is the frequency of the wave? Now with this formula, velocity equals wavelength times frequency, we can find the frequency of the wave. So 331 equals 16 times frequency, which means that the frequency will be 20.69 when rounding. And since frequency is measured in hertz, it'll be hertz for frequency. On to the next question, which is a Doppler effect question. And so here we go. A person walking in 35-degree weather hears a siren that they believe emits a 126 hertz frequency. The person begins walking toward the sound and discovers the sound keeps getting higher. What is the frequency of the siren? The person is walking at 10 meters per second. So because they gave us a degree, we can use this formula. And because it's a Doppler one, we also will use this formula. So first we're going to use the velocity one because we need to know the velocity of air. So V equals 331 plus 0.59 times 35. And this will give us 351.65 meters per second. So this is the velocity of air. And now we're going to use this formula. And since he heard 126, it's going to be the observer, which is what the O stands for. So 126 equals F, because that's what we're looking for, 351.65. Since he is heading toward the siren, it's going to be plus, and then he's going at 10 meters per second, because this O is also him, and then 351.65 minus, because he's heading toward, so it's plus minus the bottom if he's heading toward. And since it doesn't give us a velocity for the siren, we're going to guess it's not moving. And so when you get an answer for this, you divide it by that, and you should get a velocity of 122.52 hertz. On to the next question. A 450 hertz bell is heard by a moving person who assumes the frequency is 500 hertz. What is the speed that the person is moving? So we're going to be using the same formula again, And so we know that he heard 500. Well, it's actually 450. We can assume that this is an air, and whenever the person is in air, it's going to be 331. And we need to decide if he's going toward or away from the source. Because the sound is louder, or he hears a louder sound, we need to assume that he's closer to the bell than before. And since he is going toward, or we believe he's going toward, because he's hearing it getting louder, so he's gradually hearing it get more and more close. So if he's going toward, it's going to be plus the top. We don't know what he's going at. And then over 331, and we can assume that the bell is not moving, so it's going to be minus. And when we start working this out, 450 divided by 500, 1.11, and so now we have 1.11, 331 plus question mark 0, and so that's just 331, and so that's going to be times it. And so when we do that, we get 367.78, and then 331 plus question mark minus 331 minus 331, and we get 36.78 equals question mark. So he's going pretty fast. And now we're going to be using this formula with this question. The intensity of a tree falling is 10 - 6. What is its decibel level? Okay, so since we have here that this equals that, we just plug in what we do and don't have. Equals 10 log, so 10 - 6, 10 - 12. And you just plug all of this into the calculator and you should get it in dBs. And when all that is plugged into a calculator, like so, you should get B equals 60 dBs. If a radio gives off 25 BDs, then what is its intensity? Okay, so let's look at what we have. We have 25 equals 10 log I over I. We already know what that is. That's 10 - 12 over I log 10 equals 25. So divide by 10, so that's 2.5 equals log I 10 - 12. And this is where it gets a little complicating. So you put 10, 2.5, and that's going to be times 10 - 12. And so this is what you're going to do, because log does always have to do in tens. And this is how you're going to get the intensity. So that's going to equal I. And you put that in your calculator, and you should get I. So I for me equaled 3.16 times 10 - 10.